Hi guys, we're starting a new section today. It's going to be a lot of vocab, so hang in with me. Remember, you can view the PDF to go at your own pace. I'm just going to be talking through some of these concepts. Today we're going to be talking about functions, a word we've been using for the last few weeks, but that we're going to get into in more detail today. So our learning objectives are to determine if a relation is a function when given a list of ordered pairs, a table, a mapping, and a graph, and we're going to be able to determine if those relations are functions. So remember, a relation is any set of ordered pairs. That's what we did last week in our books. We saw it represented in a variety of different ways. It can be a set of ordered pairs, like we see here. Notice the set is in between these braces. That's how we know they're a set. In a table, our x values are in the first column, our y values are in the second column, and the ordered pairs make up the rows. In a map, our x values are in the first bubble, our y values are in our second bubble, and we see that the arrows point from the input, the x value, to the corresponding output or y value. So our point 2, 8 is represented by a 2 and then an arrow going to 8. Notice if values are repeated, it just has multiple arrows going to the same number. And on a graph, the ordered pairs are plotted. Keep in mind that the domain is our x values. So we have 2, 3, 4, and 5. Notice that the domain is really where we're going from left to right. And our range is our y values. We have 6, 7, and 8. It's basically where we're going from the lowest point to the highest point, are up and down. And notice that even though 7 appears twice, it's only written once. So that's all a recap from last week. This week, we're going to be talking more about functions. Now, this is information that you guys need to put in your math notebook. So you're going to be writing this down. I'm just reading through it really quickly. You are writing it down. A function is a specific kind of relation in which one input has only one output. An easier way to remember it is every x has only one y. You can think of a function like a machine. The input goes in, and as one amount comes out as another. So for example, here's 3. If our function is x squared, then as 3 goes in, we square it. 3 times 3 is 9. That's our output. These are different ways of saying the same thing. So our x values are also known as the domain, input, independent variable, and x. All 4 of these terms mean the same thing. They're all the same. On this side, we have our y values, or our range, our outputs, our dependent variable, and f of x. Again, these 4 terms all mean the same thing. We're going to go into a tiny bit of extra detail on what independent variable and dependent variable mean. An independent variable means the variable that does not depend on another. So again, that's our x. Remember, independent is our x variable. Just as a note, time is always going to be independent. Dependent variable means the variable that changes based on the other one. It should make sense that that's our y variable because y depends on what x is. We get y based on plugging an x value in. Another little note here is that total cost is always going to be a dependent variable. In an example, a large pizza costs $13. Our 2 variables are the pizzas and the cost. Well, how much we're paying for pizza depends on how many pizzas we buy. That's why our cost is dependent and our pizzas is independent. Pizzas determine how much we pay.